At the end of this media, you will know how to start a single-phase induction motor by split-phase method. Single-phase induction motor is not a self-starting motor. To overcome this drawback, single-phase motor is converted into two-phase motor during starting period. This is achieved by adding an additional winding, called starting winding, along with the main or running winding. They are connected across the single-phase AC supply, and the circuit diagram is shown in figure. The main winding of an induction motor has low resistance and high reactance. The starting winding and running winding are spaced 90 degrees electrically apart and in parallel to each other. This 90-degree phase difference is achieved by deliberately making the starting winding with low reactance by embedding the winding deeply in the core. Resistance of the starting winding is increased using high-resistance fine copper wire for winding or connecting high-resistance R in series with it. Give the supply by closing the switch S. The current IM drawn by the main winding lags voltage by a very large angle as shown in the phasor diagram. The current IS drawn by the starting winding lags voltage by a small angle. The phase difference between these two currents is alpha. These two currents produce magnetic fluxes. The phase difference between these two fluxes is also alpha, in other words, nearly 90 degrees. The resultant of these two fluxes is the rotating magnetic field. This rotating magnetic field starts to rotate the motor. A centrifugal switch is connected in series with the starting winding. It disconnects the starting winding once the motor reaches 70 to 80% of full load speed. You have learned how to start a single-phase induction motor by split-phase method.